Assalamualaikum and good day. Okay, in this video, we will look at on how to solve series if x0 is a regular singular point. Okay, previously for ordinary point, we will be using power series method. But right now, for a regular singular point, we will be using the method of Frobenius. Okay, so for the theorem, let x equal to x0 be a regular singular point of this DE, differential equation, pxy double prime plus qxy prime plus rxy equal to 0. Then there exists at least one series solutions of the form this one. Okay, y equal to summation n equal to 0 to infinity a of n x minus x0 power of n plus r, where a naught does not equal to 0. Okay, the difference in these solutions for regular singular point, we need to add here r, n plus r instead of power of n, it is power of n plus r. This is because we have the initial roots. Okay, note here where r is a constant that must be determined and r is chosen so that a naught does not equal to 0. Okay, right now, as I mentioned earlier, r is called the initial root. The difference in regular singular point, we will be having initial roots. Okay, and then the definition for initial equations here, we have that an initial equation is a quadratic equation in R that results from equating the total coefficients of the lowest power of x to 0. Okay, that means here when n equal to 0 actually, and as you can see here, it is a quadratic equation. Okay, you must obtain a quadratic equation. Let's say when you substitute n equal to 0 to obtain the initial equation, but you get a cubic equation, for example, there's something wrong in your solutions there. Okay, so the first case would be the case 1. Okay, case 1 is when the two initial roots differ by a non-integer. Non-integer here means that it is not z positive. Okay, which means here r2 minus r1 are not positive integer. Okay, positive because this is modulus. Okay, modulus is always going to be positive. Okay, right now, since the two initial roots r2 and r1 differs by a non-integer, that's why there is a slash here, because non-integer, two series solutions can be obtained. Okay, and the two linearly independent series solutions are these two. Y1 equal to summation n from 0 to infinity a of n x minus x0 power of n plus r1, while y2, the difference is here, n plus r2. Okay, for y1, here we have n plus r1, and y2, it is n plus r2. Okay, there is another way, other than when we equal n equal to 0 to find the initial equation and initial roots. The second method is to obtain initial roots by solving the equation r times r minus 1 plus ar plus b equal to 0. This is a formula. Okay, what is a? A is equal to limit x approaches x0. Here is x minus x0 qx over px, the first limit. Okay, and b is equal to limit x approaches x0, x minus x0 squared rx over px. That is the value for a and b. Okay, and note that we always denote r1 as the smallest initial root. This is very important. Okay, r1 is always going to be the smallest initial root. Okay, r1 need to be the smallest one. Okay, because for case 1 it doesn't matter, but it will make difference for case 2 and case 3. Okay, so r1 should be the smallest initial root. Okay, that's all for the introduction for case 1, and I'll explain about the examples in another video then. Thank you. Assalamualaikum.